In this video, we'll talk about three main things. Number one, we'll talk about combining like terms. Number two, we'll talk about the distributive property and factoring. And then number three, we'll talk about evaluating an expression. So first off, combining like terms. Like terms must have two things. They must have the same variable and the same exponent. And to show that the terms are like, I want us to use shapes. We're going to start off using boxes, then we'll use circles, and then we'll use a line underneath the term to show that the terms are like. And whenever you put a shape around the term, the sign before the term goes inside the shape. So if it's a plus sign before the term, that plus sign goes inside the shape. That way you know it's a positive term. If it's a minus sign in front of the term, that minus sign goes inside the shape. That way that you know that term is negative. So here's an example. We have 14y minus 4y plus 18y squared plus 24y squared. And we need to simplify this expression by combining like terms. So I'm looking at this and I see four terms. The four terms are 14y, that's a term. Negative 4y, I know it's a negative 4y because of the minus sign. 18y squared is a term, and 24y squared is a term. So in this expression there are four terms. All four of these terms have a variable y. Okay, here the exponent is 1, because if you don't see the exponent, remember the exponent is 1. So this is y to the first, this is y to the first, this is y squared, this is y squared. So 18y squared and 24y squared would be like terms because they have the same variable y and the same exponent, which is 2. So to show that these are like terms, I'm going to put them first off in a box. I put 18y squared in a box and 24y squared in a box. So this shows me that those are like terms. Notice how the sign before the terms is inside the shape. That plus sign is inside the shape. That plus sign is inside the shape. It tells me both of those terms are positive. So I need to add those together. To combine those terms or to add them together, I'm going to add positive 18 and positive 24, which will give me 42y squared. The variable y stays the same and the exponent 2 stays the same. Okay? After I use squares, then I'm going to use circles if I have any other like terms. So in the expression I have left 14y minus 4y. Okay, those are also like terms because they have the same variable y and the same exponent 1. So I'm going to put a circle around 14y and a circle around negative 4y to show those are like terms. Then I'll add them together. 14y plus negative 4y, or you could say 14y minus 4y. That's going to give you positive 10y. So because it's a positive 10y, I'm going to put plus 10y. Okay? Now I have 42y squared plus 10y. This is my simplified expression. I cannot add these together because I cannot add 42 plus 10 because they're unlike terms, and you cannot add unlike terms together. This has a variable y but an exponent of 2. This has a variable y but an exponent of 1. So that makes them unlike terms. Therefore, this is my simplified expression. 42y squared plus 10y. Okay. Next, we'll talk about the distributive property. The distributive property looks like this. So let's say, for example, I had an ice cream cone, and I'm going to multiply that by cookie dough ice cream plus vanilla ice cream. When I distribute, I am basically putting things together. So if I multiply this times this and this times this, so the ice cream cone times the cookie dough, I get a cookie dough ice cream cone. If I multiply the cone times the vanilla ice cream, I get a vanilla ice cream cone. All right. So to apply that, this is like sort of general. This is here is a specific example. This is what you will see. If we have 6 times the expression x plus 4, what we're going to do is multiply this number right here, multiply that number in front of the parentheses, times both of the terms inside the parentheses. So we're going to multiply it times 6. So I have 6 times x, and then I have 6 times 4. That's a positive 4. So I have positive 6, this is a positive 6 times 4. If I simplify this, 6 times x is 6x, and 6 times 4 is 24. Okay, so this would be my expression once I distribute 6 to the x and the 4. I get 6x plus 24. So remember, if you distribute, you're putting things together. Now we also have factoring. Factoring is pretty much the opposite of distributing. It's the reverse distributive property, you could call it. So basically, you start with things already put together, and factoring is you take things apart. You take things apart. So I already have a cookie dough ice cream cone and a vanilla ice cream cone, and I'm going to take them apart. So what do the cookie dough ice cream and the vanilla ice cream have in common? Well, what they have in common is the cone. The cone is what they have in common. So basically, I'm going to pull that out. I pull that out, and what I'm left with, if I take the cone away from these two things, what I'm left with is just the cookie dough ice cream plus the vanilla ice cream. Okay, so that would be factoring. So I'm going to use the same example, what we ended up with in the previous example, 6x plus 24, and I'm going to factor this. So I'm looking for what they have in common. So the greatest factor that both 6x and 24 have in common. Well, the greatest factor they have in common would be 6, because 6 can go into 6 and 6 can go into 24. In fact, it's the greatest factor that can go into both 6 and 24. So I pull that out, and then I'm looking for what can I multiply 6 by, what expression can I multiply 6 by to end up with 6x plus 24. So I have 6 times something. 6 times what will give me 6x? Well, if I multiply 6 times x, I'll get 6x. All right. Then I look for what can I multiply 6 by to get 24. Well, if I multiply 6 by 4, or positive 4, I get 24. So this is my factored expression. This is what I began with. This is what I end up with. I pulled that 6 out, and what I'm left with is x plus 4. Okay, so we talked about like terms. We talked about distributive property and factoring. Finally, we'll talk about evaluating an expression. So let's say I'm given the expression 6x plus 4, the one that we've been using, and I want to evaluate this. Whenever you're asked to evaluate something, you need to find the value of it. So the value of this expression when x is 3. All right, so there are 3 steps here. There are 3 steps. I would say number 1, set it up. Number 2, plug in. And number 3, evaluate. And you evaluate by following the order of operations. Okay, so set it up, plug in, and evaluate. So we're going to evaluate that expression, 6x plus 4, when x is 3. Step 1 is to set it up, which means wherever there's a variable at, you need to put a set of parentheses. So I'm going to copy this expression, 6, and instead of writing an x, I'm going to write a set of parentheses. So 6x plus 24. That's step 1. Just copy the expression, except wherever the variable is at, put a set of parentheses. Step 2 is plug in. I'm going to plug in what x is equal to. X is equal to 3, so I plug that in right there. Okay, then step 3 is to evaluate. I have 6 times 3. 6 times 3 gives me 18, and I need to add 24. 18 plus 24 gives me 42, and that would be my answer. This is the value of this expression when x is 3. So in this video, we talked about combining like terms. We talked about the distributive property and factoring, and then evaluating an expression.